Hi. Let's get to the notes. Okay, this is Unit 1, Lesson 1. It's about variables and the order of operations. Objective: students will review the principles of variables and the order of operations in order to calculate an expression for a given variable. So let's say I gave you this set of instructions. It's hold down right, then tap A, tap left and A, hold down right, tap A twice, tap left and A, hold left, tap A, but I can't even read it that fast. We're still going with 25, 26, 28. You see how these instructions are almost impossible to follow. There's too many instructions. Even if the only instructions are right, left, A, B, there's 58 of them. It's too hard to remember all those instructions in a row. But the thing is that it's something you already know how to do. That set of instructions tells you how to beat level 1-1 of Super Mario Brothers. And so much like you don't remember exactly what buttons you push when you do a video game, you're not going to remember every single step of doing a math problem. I'll get to the end of the level soon. I'm going to cut it off short. There it goes. Okay, end of the level. Okay, step-by-step instructions are not going to work. It's going to be too many instructions to remember. The point I'm trying to make is if you spend the next 9.5 months trying to remember every step for every problem, there's two things that are going to happen. One, you're going to be confused all the time. And two, you're going to make the class harder than it really is. So instead of remembering step-by-step instructions, what you want to do is you want to take the rules you already know. We're going to apply those rules to some new situations, and we're going to see what happens. And if you do that for every problem you have, you're going to take things you already know and learn new things about them. So to start, let's take this simple expression, 1 plus 3 plus 2. Now I have a question. Does the order matter when I add 1 plus 3 plus 2? Now if I don't know, the only way to figure out is to do it. So let's take 1 plus 3. I have 4. 4 plus 2, that's 6. Again, everything you already know. But what about the other way? Do I take 3 plus 2? Well, that's 1 plus 5, right? 3 plus 2 is 5, and I add the 1. That's 6. So when I add, and I found this out by experimentation, not by some rule somebody passed from above, when you add, the different orders give you the same answer. So the order doesn't matter when you add. But what about subtracting? Well, 3 minus 1, that's 2. 2 plus 2, that's 4. Okay, let's try it the other way. 1 plus 2, that's 3. 3 minus 3, that's 0. Oh no, now we have different answers. We have to figure out which one's right. So let's just ask which one makes more sense. Well, if I take 3 plus 1 minus 1 plus 2, and I get 3 minus 3, well 3 minus 3, that's the same thing as taking 3 minus 1 and then minus 2. And it doesn't make any sense to have two problems written differently. The change of sign is the only thing different, and have them be the same thing. It doesn't make sense. Why would you write that? That's not the right way. So the rule is when you're going from left to right, when you got addition and subtraction, left to right is the way to go. Now does that apply also with multiplication? Well, let's see. 2 plus 3, that's 5. 5 times 4 is 20. Okay, 2 plus 3, or do I do 3 times 4 first? Get 12. 2 plus 12, that's 14. That's another mistake. Those are different answers. 20 is not the same as 14. So one of those is right and one of them is wrong. Now I'm going to examine this one. I should be able to rewrite this problem as an addition problem because as you learned in 2nd grade, multiplication and addition are the same thing. Multiplication is just repeated addition. So if I take 2 plus 3, that's 5 times 4, that's 5 plus 5 plus 5 plus 5. Now that doesn't make any intuitive sense that it would be 5 plus 5 plus 5 plus 5 because I can't rewrite 2 plus 3 times 4 as 5 plus 5 plus 5 plus 5. Okay, no, just like the subtraction, I'm not multiplying the 2 and the 3 by 4, so that doesn't seem to be right. Now let's take the 3 plus 4. Now you see I can write without doing the first step of the problem. I write 2 plus 3 plus 3 plus 3. I can rewrite it as an addition problem. And I shouldn't get 13, I should get 14. Keep that in mind. Now that makes much more sense that I can rewrite it as an addition problem. Now what about division? Where does that go in this whole? Conclusion is that multiplication you should do before addition, no matter where it comes up in the problem. Now what about division? Well, addition, the inverse of addition, when you undo addition, we call it subtraction. And so you did addition and subtraction, quote unquote, at the same time, meaning from left to right in the problem. Multiplication has an inverse called division. So just the same way addition is related to subtraction, multiplication is related to division. So you do multiplication and division left to right through the problem. What about these? Let's look at exponents. So if you look at this, and this is, remember we just did this with multiplication. If you do 2 plus 2 plus 2 plus 2, that's the same thing as saying 2 times 4. So if you do repeated addition, you get multiplication. So when you're doing a problem, you do multiplication first and then the addition. Now similarly, if I do repeated multiplication, that's called an exponent or a power. So if I do 2 times 2 times 2 times 2, I get 2 to the 4th power. So just like repeated addition, called multiplication, comes before addition when we do problems, then repeated multiplication, called an exponent, comes before we do multiplication in the problems. Now the question is, what if I want you to do addition? What if I design the problem and I don't want you to do the multiplication first? I want you to do the addition first. Well, in that case, I'd put parentheses around what I want you to do first. So parentheses comes before everything else. Now to change gears from the order we do the problems in, if we only use numbers to do math problems, then every math expression, everything you do with math, if you just use numbers, can only be used to represent one situation at a time. And that's a unique situation. It can't be applied to anything else unless it's the exact same situation. That's pretty boring. That's pretty useless. It doesn't really help us out. So in order to be able to make an expression that can apply to different situations at the same time, we use variables. Now a variable is a letter that we use instead of a number. Most often we use X, but you can use any letter. I would advise against using letters like O that look like a 0. But it could be any letter. Now this variable could be anything. I don't know what it is. It could be -1. It could be any series of numbers. It could be something that isn't even a rational number. But so let's take those two x's. What I do know about those x's is that those x's could be any number, but since they're both the same letter, I know that whatever number it is, it's the same number. All the x's will have the same value. If I wanted a variable that could have a different value, I would have to use a different letter. So once you know what the number of variable represents, you can just replace all of them in the problem. This is called substitution. And then you can use the order that we talked about earlier in the lesson to simplify it down to one number. So in this case, let's say our x is equal to 2. Well, in that case, I replace all of the x's with 2's. And notice how when I did that, I used parentheses. It doesn't seem like a big deal now, but it's really important that when you substitute, when you replace a variable with a number, you use parentheses around the number when you do it. So in this case, we decided that exponents come first. So 2 squared is going to give us 4. 4 times 3 is going to be 12. Then we do multiplication on the other one. So that's 8. 4 times 2 is 8. So we have 12 plus 8, which is 20, minus 7 gives us 13. So we simplified that expression for that given value of the variable. On the next page is your homework, and I will see you for the next lesson.